Electronic Project 1. Design a DC power supply with voltage regulator. Now DC power supply, you can see it in almost any electronic equipment, from cell phone, computer, anything. Okay, the DC power supply is basically the source of the power. So the first electronic project video here is to learn about this DC power supply, and hopefully you will have one to use it for the later various project. The DC power supply, you need a 5-volt power supply for the digital circuit, and the analog circuit typically 5 and 12 volt, and what you need is a DC power supply. So how do you get the DC power? Because most of the home outlet is 120 volt AC. So the easiest, there are two ways to make a DC power supply in the industry, and the simpler way is to use voltage regulator, and this is a low cost way and most accepted way. So we learned this first, and the second video, back-to-back converter type of DC power supply, I will explain to you what is advantage and disadvantage. So here you go. This is the typical power supply unit, and this is 120 volt AC coming in here, and you see this label here is 12 volt 8 amp and 5 volt 1 amp, right? So this power unit is going to produce 12 volt DC and 5 volt DC. And what is the output of the DC? The capacity of power supply is 8 amp for 12 volt and 1 amp for 5 volt. So here's the output. This is 12 and this is 5, and you can connect the ground. One side is ground common, so this is going to serve most of the electronic circuit. You see on the left side, you see the breadboard. We're going to use the breadboard for various electronic project in this video series, and use this voltage supply. It's low cost. It's like $10 or less. Okay, we can get this one instead of using a fancy voltage supply. And this is the electronic project at the low cost. So everything we use is a low cost. Here's a voltmeter. Okay, let's start. So as I said, every electronics has at least one DC power supply. DC power supply, some need AC, but most of them need the digital. So here's the design objective is you have a wall outlet, you plug in 120 volt and 50 hertz in the US, and AC-DC power converter. The first method is using voltage regulator. The second is back-to-back converter, and this is gonna be next video. And objective is to get the 5 volt, very common for the digital circuit, and 12 volt for analog, and 3.3 volt for CMOS. Okay. So first, when you say 120 volt, what does it mean? It's actually RMS. Okay, so V is not really the peak voltage. It's called RMS, is the root mean square. And what it is say you have a peak voltage and sine wave by ft, this equation. What you do is you square for the period 0 to t and divide by over t and take a square root. So this is the Rms voltage, the definition of R, and it's much smaller than peak voltage. So the outlet is 120 volt. We're talking about RMS. Why use RMS? Because RMS, the voltage and the current multiply, we get the power wattage. Okay, so that's why RMS is important. So you have a VP, peak voltage, and the sine wave, and you use this integral. The ft square is 1 over 2 minus 1 cosine 2 omega t, right? Okay, so this is based on trigonometric formula, and you take a average. We calculate the average. This another one is a V average. What is a V average? Is you take a half, right, and take an integral, divide by period. Then you get the V average. V average is about 0.6 of peak voltage. Okay. On the other hand, the RMS is 0.7 times VP, voltage, peak voltage. So after you did calculation, the RMS times square root 2 is going to be VP. So you have a two different voltage. So you should know this average become important later for the second video to design the back-to-back converter. But here the power is given by this. So peak voltage is actually much bigger, about 140 volt peak or more. So this is the basic stuff you have to know about the AC voltage. So this RMS is step-down transformers. The voltage dropped because it's too high. And diode, there are type 1, type 2. Diode is going to make it the DC. DC is accumulated here. So diode circuit, they change into this kind of waveform, and after filter it's become like that, and the voltage regulator regulated to constant, say 5 volt, if that's the final voltage you want. And here it's going to be rippled voltage. The filter does most of the work, but not perfect. Okay, so 3 stage we have, and when we design the voltage power supply, then we calculate backward. What is the requirement? 5 volt and 5 amp. Okay, to get the 5 volt, what is V1 here? Voltage regulator need couple volt drop, so minimum 7 volt here, right? To get V1, what is V2? The 7 volt, it's rippled, so maximum has to be like a 9 volt. Okay, and to get the V2, what is N1, N2? N1, N2 is 120 volt, 9 volt. Again, this is not the peak voltage. Okay, so that's the way you calculate. Then you know ratio, what kind of stepping transformer you need to drop the voltage. Okay, so here it said V1 is V out plus about 2-3 volt, 8 volt, and we need a 5 amp. So the power wasted in the voltage regulator is 0.5 amp. So we need 3 volt times 5.5 amp. Okay, to get V2, we got this. This is a V2. Okay, so now the diode circuit, it can be single diode. Okay, so it's going to be like that, and the reverse direction, you get very tiny amount of current and go like that. So it's almost negligible, right? Now bridge diode, you can make a bridge configuration, then we can save the power for every cycle. Okay, so V3, the ratio is, let's calculate this. The V3 is Vp, the Vrm is 120, ratio is N1, N2. Type of transformer, the current ratio into N1, because P equals Vi. So here the transformer, the voltage drop, but the power on this side is equal to this side. Okay, except for some power loss due to a small resistance on the coil. Okay, so 120 volt, and here's 9 to 10 volt. Then the current ratio is this opposite, N2 to N1. So this current, you expect to be 10 times more. So this step-down transformer typically has much thicker wire for this side to manage larger current. This current, this side, is very small. Okay, so that's the transformer, step-down transformers design. And filter circuit. Filter circuit is the electrical engineer knows this. The impedance, you set the impedance and calculate the V out from VE, and you get this equation, this frequency. So when frequency is 0, then VE equals V out. That means the DC component of VE, V in shows up in the V out, and the ripple come from next higher frequency, which is like a 50 hertz. Then the basic V out has ripple running, and the higher frequency has more ripple running, and so on. So, but it gets smaller and smaller. So, like if you use a Fourier component, you see frequency, and there is a 0 and 50 and 100 hertz. So distribution goes like that, and filter cut off some point. So you have a DC component with a ripple of 50 hertz and a little bit higher frequency. Voltage regulator is a single chip, IC chip. Okay, so unregulated input, this is a rippled input, and the regulated output is going to be very steady voltage. And this conversion is done by single IC chip, and it has a several protection. Overload protection. Overload means if you draw current too much, like a short circuit, then this protection circuit shut down output voltage, because otherwise too much current flow and it's damaged IC chip, right? And the voltage reference is very stable. And stable against what? This ripple and also the temperature. Okay, but the problem with the voltage regulator is, as I said, there is a voltage drop between input voltage and output voltage. This drop is like 2 to 3 volt. So the current, if you provide the same amount of current, then this much it's wasted inside. So that much power is wasted. This is a problem with the voltage regulator. It's easier design and well-known method. This is the example of a small voltage regulator type. This provide 5 volt and 3.3 volt for CMOS logic. This take standard 12 volt, and this is the voltage regulator here. Okay, and the capacitor and some coil, and this is diode here. So simple voltage regulator, power supply, very small. Here you go. You see, oh, this is 9 volt input, 9 to 12, and a diode, a capacitor for filter circuit, LED, and resistor. And this is the voltage regulator, 2 different voltage regulator, 5 volt and 3.3 volt. If you look at the circuit, it's very simple. Just make sure it's if you apply the wrong polarity, it doesn't break the circuit. This diode protection, and LED lights up when the power is applied, V in. It can be unregulated rippled voltage. And this is the capacitor, and this has a rippled voltage go to the voltage regulator for 2 different output voltage. Okay, so it's very simple, but obviously it has the say if this is 9 volt and I, so it's going to be I plus delta 9 minus 5 volt, I plus delta is going to be power wasted here, and same way here, this is more power is wasted. So the problem with voltage regulator type of power supply is wasted power. Now you look at the original, see, you see the huge heat sink, and this is the 8 amp 12 volt. The heat sink is going to dissipate all the power wasted here, and this one is 5 volt 1 amp smaller heat sink. Okay, so if you see heat sink, you can tell this is the voltage regulator type power supply unit. Okay, move on to the next video, which I talk about the back-to-back converter, or it's used to be called switching regulator. Okay, so let's move on.